Hi, good morning. This is the CAP warm-up for Wednesday the 20th. Please pause and complete these. These definitely take some of the stuff we've learned the last 2 days and takes it to another notch. Definitely brainstorm and then come back and we'll solve it together. All right, looking at the first one, if PR is equal to QR and the measure of angle R is 30 degrees, find the measures of angles P and Q. Okay, so it can be a lot of information. Chunk it into pieces. How can I show that PR and QR are equal or the same length on my thing? Dune? Repeat that one more time. Yeah, so, and I can show that with the tick marks. Yes, okay, so PR, this length right here. Oh, Lord, all right, so I can mark that they're both equal. They are isosceles with those tick marks. Measured angle R is 30, so I'm going to go ahead and label that right there. And we need to find the angles of P and Q. So I have two missing angle values. Ooh, what can I do? What can I do? Carolyn.
So all of like the add up all angles.
Yep.
And that's 30 degrees. And so PR equals QR, which means that angle
Very good. We talked about that yesterday. The angle's opposite. So angle Q controls this side, and then angle P controls that side. You said, what about those?
The angles are the same.
Correct. I don't know if I've mentioned this yet, but just like we can mark tick marks to show equal lengths, you can also do that on angle measures. You'll see that more later on in life, but just letting you know that angle measures, if they have tick marks, again, the same amount of tick marks means the same length. Okay, keep going, Carolyn.
Okay, so we know now we know like the R equals 30. So
Yeah.
we subtract 180.
Yes. Okay, so taking 180 and taking away the angle measure, we do know that gives me 150.
And then you divide by 2.
And because they're both equal, we can split those. That 150 needs to be split equally amongst the two remaining. Okay, so I would divide this by 2. 150 divided by 2 is 75. Okay, you could also work it the other way, saying, okay, like getting this far and saying, okay, well, if this is X, this is also X. So you can say X plus 30 is equal to 180. So that's 2X plus 30 is equal to 180, and then solving with those same steps. If you needed to write an equation, that's sort of how it all ties in. Are we sort of understanding that now that we see it? Again, if you didn't see it before, maybe you're like, okay. Any questions before we move on? Second one. What do we think? Did you get an answer, Saki?
I got an answer.
Okay.
I'm not sure if it's
Okay, walk me through it. Yeah.
So for X, what I did was on my first one, we didn't get like the X, but they all. Sorry, let me reword that. There's X in each expression.
Yeah.
That means X equals the same amount.
Mm-hmm.
So what I did was I did 5X plus 4X, and got 9X. Then I added the other X and I got 10X.
Mm-hmm.
And then the negative 4 plus 3, I got a negative 1.
Yep.
Then I did the 10X minus 1 was 180.
Mm-hmm.
And then I solved that.
Yep.
So should I tell you?
So I'm going to catch us up to where she's at. She's doing exactly what you need to do. I'm going to do it in a little bit different order, but it's going to be the same thing. So I see a triangle, and what do we know about the triangle? The angles of a triangle, we know. Yes, there's two cubes from what I'm looking, but more specifically, I know someone was saying it. They add it to 180. So what I'm going to do is I'm going to take this expression plus this expression plus that, and I'm going to say those three added together equals 180. So I'm going to say 5x minus 4 plus 4x plus 3, 4x plus 3 plus x. All of that equals 180. Okay, if it helps you to group things, that's also fine. So that's the first angle, the second angle, and that third angle. Do you see how I did that? I added the three expressions. Y'all good with that? Okay, take a pause and write that down if you need to. Okay, and then what Saki was explaining, what she was sort of explaining that she did, is she combined her like terms with like terms, meaning all the x's with x's, all the constants with constants. So we have 5x, 4x, and just regular x. Together that makes 10 10 x's. Okay, then the constants, we have -4. Remember, it takes a sign in front of it. -4 and +3. Together, that would make -1 or -1 is equal to 180. And that's what she said. She combined it. She just didn't write well, she might have written the equation on her paper, but as she was explaining it, she just did it while I was up here on the picture. But it's the same thing. Okay, then class, what do I need to do first to get x by itself? Add 1 to both sides. Cancels out. 10x is equal to 181. When I divide by 10, all that does is moves that decimal, so x is equal to 18.1. Is it okay that x is a decimal? Yeah. Doesn't matter. Okay, so if you need to take an extra second to copy that down, definitely do that. I'm going to pause real quick and read this so y'all can actually see it. All right, moving on. I'm going to go over homework key with my class, and then we'll pause and play for the lesson. I'll actually go ahead and explain this. We're talking about number 1 in this problem. So a lot of times, especially with geometry, when it's talking about different things and it doesn't give me a picture, pictures really help. I'm just speaking the truth. So it's saying in triangle ABC. So I'm going to start with the triangle. I'm going to label it A, B, and C. Okay, it says if AB is congruent to side CB. AB is congruent to CB. I just put those tick marks to mark the congruence. Y'all good with that? Okay. AB is congruent to side CB, and the angle A is congruent to angle B. So angle A right here is congruent to angle B. So those two are the same. We need to figure out what must be true about the triangle ABC. We're just trying to find some facts, some truths about that. Okay? So what are some things y'all notice, or maybe you're reading about in the explanation? Andrew.
A and C have to be equal to each other.
Why? Sides AC or angles AC?
Angle A and C.
Angle A and C because? Yes, because of the two, yeah, because of our two congruent sides, we know that the angles opposite those congruent sides, the angles are going to be equal to. So the one that controls this side is angle A, that's congruent, and the angle that controls this side right here, the one is opposite, is also equal. Okay, so what have we just established about that triangle? It's going to be equilateral. Okay, because this pair over here and that angle over there, because those sides opposite, so I could also say, because I know that this angle is equal to this angle, I also know the side opposite from them. So this one is going to be the same as this one. Does that sort of make sense? How you just piece all the things together. So it's an equilateral triangle because side AB and CD are congruent, blah, 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 blah. Picture, picture, picture. I'm not going to read all that. Any follow-up questions? 10. This one? 9. In an isosceles triangle, the third angle is 10 times the measure of each of the congruent angles. What is the measure in degrees of the largest angle? So they have the picture. I'm going to draw it a little bit bigger. Again, it really just helps when you do this. So in an isosceles triangle, I'm going to say this one is equal to that one. The third angle is 10 times the measure of each of the congruent angles. So I'm going to start with the congruent angles. So the one that, let's call it P, Q, R. The two angles that are congruent are angle Q and angle P. Those two are congruent. You good with that? Okay. I don't know any of the measures, but I know that this third one, angle R, is going to be 10 times the amount. So if I said that this was X, I know this one also has to be X because they're the same amount. Because it's 10 times the amount, I'm going to do 10 times that unknown amount, 10x, to get that thing. Then I know that the sum of my three angles is equal to 180, and I can combine my terms. X plus 10x is going to be 12x. I can combine that to be 12x, and then divide both sides by 12 to get 15. Okay? And then to find, so that means that each of these is 15, and then this would be 150 because it's 10 times that 15. Yep. Last question on the second page. This one, 15. The construction scaffolding shown here is made in part of an equilateral triangle with side lengths of 30 inches. Write and solve an equation to determine the value of x. Give me a second, let me look at this one. All right, so it was saying that it has the equilateral triangle, so like it's saying this right here is an equilateral triangle, and it's saying that this is 30, and we're trying to solve for this. We know because it's equilateral that all the sides are the same, so that 30 side length is the same as that side length. So they said it's equal to each other, solve for x. Okay? Labeling those different pieces. Any other questions? Yep.
Number 11.
This one? For y? Okay, y, I see it's talking about a side length. I also noticed that this is an equilateral triangle, so I see that 12y is going to be equal to 3/4. So I need to solve for that. They said 12y is equal to 3/4. To get y by itself, I divide by 12 and divide by 12. In order to divide a fraction by a whole number, I'm going to turn them both into fractions. So that would be 3/4 divided by 12 over 1. But when I divide by a fraction, class, that's the same thing as multiplying by that reciprocal. They cross-simplified before they multiplied. They divided 3 and 12 by 3 to get 1 and 4, and then they multiplied across. So 1 times 1 and 4 times 4, 160. Okay? I also know it's going to be a fraction because 12 to get, if I'm multiplying a whole number and I end up with a fraction as the answer, I know I'm going to have to multiply it by something less than 1. I love all these questions. These were good, like, thinking questions to get that right there. All right. So we are going to go into this lesson. Let me see what this video is before. Come on. All right, here we go.
Welcome to Gauthmath. In this video, we're going to talk about how to build a roof on top of your house.
Okay.
Now, just kidding. We're going to introduce the relationships between the sides of a triangle to you. But if you learn it well, you could not only get an A in solving triangle questions, but save money when you're buying materials for roof repairs. Let's say you want to build your roof in the shape of a triangle. You know, the one that will survive in a tornado. Presume that your roof is 4 meters long. There are 4 lengths of wooden sticks, and you have to choose 2 from them to build your roof. How would you choose the right sticks with the proper length to construct the triangle roof? Which 2 of them could help? Let's say you picked up a 1 meter stick and a 2 meter stick. Now try to build up a triangle with a base of 4 meters. They'll never make up a triangle. Is this because we chose the shortest 2 of the 4 lengths? Let's try with 2 2-meter sticks. Well, not going to work. However, if you pick up a 2 meter and a 3 meter stick, you'll find that they can construct a triangle. So why have we failed to get triangles in our first 2 attempts? Well, you must have noticed that it's because of the lengths of the sticks. We can't randomly choose 3 lengths to construct a triangle, and that is to say, there are certain constraints on the side length of the triangle. The first constraint is that the sum of the lengths of any 2 sides must be greater than the third side. That's why we fail at the beginning. 1 plus 2 is smaller than 4, and 2 plus 2 equals 4, but not greater than 4. Finally, by choosing a 2 meter stick and a 3 meter stick, we successfully build up the triangle. 2,000 years ago, mathematician Euclid wrote in Euclid's Elements that the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. This great discovery was mocked by the other mathematicians at the time. They believed this triangle constraint was useless, since the shortest path between 2 points is always a straight line. Thus, the sum length of any other paths would always be greater than this straight line. Here's a puppy sitting at point A. You put a bowl of food at point C, and there's a tree at point B. Without any surprise, your puppy will run straight towards the food along AC, instead of running out of its way, AB plus BC, unless it's not hungry and wants to take extra exercise. Thus, we get the Triangle Inequalities theorem by the inspiration of Euclid. There's another constraint of constructing a triangle. The difference of any two sides of a triangle is less than the third side. This one, together with the previous constraint, are known as the triangle inequality theorem. Now, let's go back to building up a triangle roof. In order to help you, your neighbour Lucy brought 4 bunches of sticks for you. We already know from the triangle inequality theorem that the sum of any two sides is greater than the third side, and the difference of any two sides is less than the third side. In option A, 5 plus 5 equals 10. We can rule it out. Likewise, option C and D can be ruled out. Take a closer look at option B. 6 plus 9 is...
Sorry, I'm going to pause that just so y'all can see that. So again, A doesn't work because 5 and 5 gives you equal to 10. On C, if you take those shortest two, 5 and 7, that gives you 12. It needs to be what then the other one? It needs to be greater, so it doesn't work. On here, 6 and 4, those would be 10, which is less. And so, sorry, I just wanted to give y'all a chance to...
greater than 13. The first constraint is checked. And 13 minus 6 is 7, which is less than 9. Second constraint, checked. So the answer to this question is B. Remember to check both of these two constraints when you try to construct a triangle next time. Have more questions about the relationship between the sides of a triangle? Find an expert to help you on our app, Gauthmath Homework Solver, step by step.
All right.
It was what
better. I think my story is better, but that gives a nice visual. We really don't focus on the second part of that inequality too much this year, where you're subtracting the difference. All we're really going to be focusing on is like the two sides are always less than the third. They are greater. The sum is greater. Yes, ma'am. Yeah. Yeah. Okay, equilateral. So let's take an equilateral. Give me a side length for an equilateral triangle. 4, 4, 4, 4, and 4. So again, the theorem says that the sum of two sides needs to be greater than the third. So 4 plus 4 needs to be greater than 4. 4 plus 4 is 8. Is that greater than 4? Yes. Okay. It still follows that rule. Okay. Great question, because I get you would be thinking about that. All right. So the triangle inequality is basically what we're focusing on today. And the triangle inequality states that the sum of any two sides must be what's in the measure of the third side. It must be greater. And that makes sense in my mind, because when you add two things, it should be greater. It should be more than the other one. Just standalone. Okay? And again, you should be able to do this with any pair. So A and B, A and C, and B and C. If you do any combination, it should always be greater than the third. Now, lots of times you can eliminate answers just by taking the smallest two and making sure it's bigger than the longest. Okay, and you'll see that when we practice right here. So as soon as you know that the sum of any two sides is less than or just equal to the measure of the third, you know it cannot make a triangle. So let's determine. So I'll do the first one with you, and then I'll let you do B, C, and D. So I always take the shortest two and check that. So in triangle A, we're at 3, 4, 5. I would do 3 plus 4. Is that greater than 5? Yes. Okay, so yes, this works. I want y'all to try it on the other 3. Pause and play when you're ready to check. On the second one, yes or no?
No.
No, because
7 plus 2 equals 9.
yes, very good. It needs to be greater than, but that does not work. Okay, take the shortest two. 1 plus 2. Is that greater than 4?
No.
No. If I take 7 plus 7, is that greater than 12?
Yes.
Yeah. Okay, are y'all getting it? 7 plus 7. I take the shortest two. That's the quick way to check it. Okay, you're not okay. Yes. Okay, because I bet quite a few of y'all did 12 plus 7, and you're like, yes, that's greater than that 7. That is true. But you have to check it for all. And again, usually the one that's the tail, the one that like shows its weaknesses is when you take the shortest two. Okay, so that's why we're practicing it. It's new, but it's not too bad. All right, then the rest of the notes today are pretty much tied in with yesterday. It's just re-discussing it. Yesterday we learned that a triangle is isosceles and the angles opposite those congruent sides are congruent as well. In an equilateral triangle, since all 3 sides are congruent. All three angles are congruent. And they always equal, the angles always equal, not 180. Each angle is 60. Okay, that's always true in an equilateral. In a scalene, there is a special relationship between the long side and the largest angle, and the shortest side and the smallest angle. Technically, I would say this isn't just true of scalene, it's true of all triangles. There's a relationship between the angle and the side that's opposite, and we talked about that yesterday. So let's just use this scalene for example. So let's call this triangle FGH. Okay. So looking at that one, which looks to be the smallest angle? Angle FF. I would say it's probably the smallest angle. Okay, I'm going to label it smallest angle. And therefore, yesterday we talked about which side should therefore be the shortest. Side GH, the one that it opens up to, the one that is across from it. This should be my shortest side. Okay? Now, I don't want to teach you bad habits of like eyeballing things, but if you had to eyeball which is the largest, or sorry, which one is the longest side? I'm sorry? I would say FH is probably longer, longest side. I'm just going to let that know this is my longest side. So therefore, which angle is going to be the biggest? Angle G, the one that is across from it. Okay, it's also the only angle that's not touching it. Angle F and H are touching it. The one that's not, the one that is across, is going to be my largest angle.
So is it the one that's closer to it?
Nope, it's the ones across from it. Technically the furthest.
Yeah,
Because
that one has
Michael, because H is touching it, F is touching it. It's the farthest, not the closest. It's technically the farthest. It's the one across from it. From this side, it's the one across from it. Yes, ma'am? Okay. All right, so what do we notice about the largest angle and longest side? They are across from each other. Okay, the same thing, I'm not going to rewrite it, but the same thing can be said about the smallest angle and the smallest side. They are across from each other. Okay, we can use this information to help us do more math. Yay! 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 Okay, so we are going to order the side and the angles based on the relationship. All right, so what we are going to do is it says to order the sides of the triangle from least to greatest. What order? Least to greatest. By side length. Be sure to correct the notation of your. Be sure to use the correct notation for your angles and sides. So, what do we notice about this triangle? They gave me the angle measures, but it tells me to order the sides. Okay, so we got to use the information to do that. So we want to start least to greatest. So which angle do you want to start with probably? The smallest, angle S. So that's going to be my smallest angle. So what side is that controlling? TR or RT. Okay, so side RT. Then, so that's going to be my longest. That's going to be my, I always do like a small, medium, large. You don't have to use small, medium, large. You can do 1 to 3. That's my shortest side. Which one's my medium angle? Angle T. So that controls RS, side RS. Someone coming, please stop. Side RS. That's fine. And then lastly, that one. Side ST. So I like the alphabet. Okay? Are y'all seeing that? On this next one, it tells me to order the angles, but it gives me the sides, okay? This one we're also going greatest to least. So, which one's my greatest side? MN, what angle controls that? L. Okay, so that's going to be angle L. Next one would be LN, which is controlled by angle M. And then lastly, this side, which is controlled by the one opposite, angle N. Now, I'm going to change your life just a little bit to make it a little bit more complicated. Now, this is the correct way to write those angles. As we talked about the little angle symbol, it looks like the less than symbol, but it has a flat bottom. That's the difference. It has a flat line. Okay, there's another way to write the names of angles. So let's look at angle L first. Okay, angle L is talking about this angle right here. Okay, I'm going to highlight the whole angle. Do you all agree with that statement? Okay, we say it's angle L because that's where the point is. But there's another way to notate for angles, and that's instead of using 1 point, we use 3 points. So I can also say that this is angle M. Stop. Angle M L N. Okay. The order when you use 3 letters, you start end point, vertex, end point. So you do N L N. You could also call it N L M. Okay. The big thing to check is that the middle letter is that vertex of the angle, it's the point of the angle. Do y'all see that? Okay. Let me do another one. Let's look at angle M. Angle M is this one right here. Angle M is this one right here. So I can call it angle M, or I can do a start, middle, end. So it could be angle N, M, L, or you could reverse that order, L, N, N. But that middle is angle N. Yes? Yeah. Okay, so starting maybe with angle N, if I just start right here, how do I figure out the sides from that? Give me an example and I can help you out. Yeah. So like on this one where I had to order from greatest to least, okay? So because I'm looking for the greatest angle, I'm going to look for the greatest side first. So I have 5, 13, and 12. Which of those is the greatest? 13. So that is this side right here. We have to think to ourselves what angle controls that. It's the angle that is across from it. So that was angle L. Okay, then we said 12 would be the next biggest. That's this side right here. What angle controls it? The one opposite. So that's N. So on and so forth. Okay, so like on the first one, okay. So we were going from least to greatest. So I see those 3 angles. Which of those is the smallest angle? 53 is my smallest angle. It controls the side that is across from it. So RT or T color. Okay, it's just going across. Okay, so back to this. Looking at angle N. Looking at angle N. Does anyone want to try and give me the 3 letters that would identify them? Carolyn, go for it. L, N, N. Angle L, N, N. Again, the key thing is that the middle one has to be the vertex. Okay? You could see either one of these notations for the angles. You're going to be confused. I'm just letting you know. Okay? But yeah. So what I want y'all to do now is practice with these next ones. So something to keep in mind. We want to order all these from least to greatest, but remember, if they give you the sides, they want the angles. If they give you the angles, they want the sides. Okay, they always want the opposite of what's given. So take a few minutes, pause and play.
What if they give both ones?
They don't. All right, so we're just doing the first one because I need to do some work on with y'all. Okay, we're going from least to greatest. So I want the smallest, or sorry, the shortest side, which is the shortest side. 17. What angle controls that? Angle H. What is another way to write angle H? Let's try it out. Angle GHF or angle FHG. Either one. Okay, then the next one would be 21 would be the next longest. The angle that controls it is angle F, okay, or angle GFH, or angle HFG. Again, that middle stays the name of it. Lastly, longest one is 35, controlled by angle G. Okay, so angle HGF or angle FGH. You do not have to write all 9 combinations, okay? You just pick one, go with it. All right, yes, real quick. Yeah. Number 2, since it gives you the angles, you're looking for the side, so you would say like side AB. Okay, I'll set that down. All right, I want to do a few word problems with you, so you're not totally lost on the homework. Honestly, I'm going to do number 6 just because I know it's a Sykes one. Number 6 says the triangle has side lengths of 3 inches and 6 inches. What are the possible whole number lengths of the third side? Okay, this goes back to that triangle inequality where it says that any 2 sides needs to be greater than the third. So let's say that 3 and 6 are my 2 shortest sides. 3 plus 6 needs to be greater than that third side. So what are the possible lengths? 3 and 6 gives me 9. What numbers would suit that? Okay, so I can't have 0, obviously. Okay, so 1, 2, 3, 4, 5, 6, 7, and 8. I can't have 9 because it cannot be equal. Now, these are still not all the possible answers. Okay, because what if, okay, 6 is the longest side. What if I have 3 and like 1? 3 plus 1, is that greater than 6? No. What about 2? 3 plus 2, is that greater than 6? 3 plus 3? No. 4 plus 3? Yes. So these are my possible lengths because I have to try different combinations. I always have to take the shortest 2. If these are the shortest 2, I got all these numbers in purple, but then I was like, wait, if those are if you rearrange it, then it also needs work together. Okay? Because of time, I need to explain this last piece. Yeah, I never did that. Next practice. Something that you need to do for homework. You have 2 parts. First off, you are going to have a quizzes. Remember how I said that there was a minor ticket sometime this week and it got moved? It got moved to tonight. Okay? So what's going to happen, I've already posted this quizzes in Canvas under announcements for my classroom and Slido. What you'll need to do is you'll go complete this quizzes tonight. You must complete it tonight. You have 2 attempts. I'll take the highest grade, and you must do it by 11:59. Okay? It doesn't show you the right answers when you do it. You need to make sure you practice that. And then I'm not going to be too picky, but if you can, please do the odds tonight as well. The quizzes is a higher priority because of it being half of the minor.
Okay,
Thank you.
The quizzes